my club.
Newton's law of cooling can be modeled by the differential equation d capital T over d small t is equal to negative k quantity T minus Ta. The first thing we need to do in order to solve this problem is to look for the general solution. This differential equation can be solved by the method of separation of variables. What we do is to divide T minus Ta to both sides, and so therefore we're going to have this equation dt over T minus Ta is equal to negative k dt. With this expression, we can now integrate both sides. Integrating both sides, we now get ln of the absolute value of T minus Ta is equal to negative kt plus an arbitrary constant c. To solve for c, we use the following initial conditions. At t is equal to 0, t is equal to To. Using this information, we now substitute these initial conditions to our previous equation. By doing this, we get ln of the absolute value of To minus Ta is equal to 0 plus c. Solving for the value of c, we have c is equal to ln absolute value of To minus Ta. The next thing we have to do is to substitute the value of c to our previous equation that we have obtained using separation of variables. We now get ln of the absolute value of T minus Ta is equal to negative kt plus ln of the absolute value of To minus Ta. Next is we transpose ln of the absolute value of To minus Ta to the left side of the equation, which can be expressed as ln of the absolute value of T minus Ta all over To minus Ta. Solving for t, we now use e raised to the left side of the equation, which is ln absolute value of T minus Ta all over To minus Ta is equal to e raised to the negative kt. The e and the ln will cancel out each other. We are now left with T minus Ta all over To minus Ta is equal to e raised to the negative kt. Solving for t, we now have the general solution for the separable differential equation T is equal to quantity To minus Ta times e raised to the negative kt plus Ta. The next thing we do now is to tabulate the data we have obtained from the neighbor of Mr. X for the investigation process. The body of Mr. X was found at 6:30 a.m., so we set T equal to 0. The temperature of Mr. X's body recorded by his neighbor was 76 degrees Fahrenheit. That will become RTO. After an hour, which is 7:30 a.m., we set T is equal to 1. Mr. X's body temperature was recorded again by his neighbor, and this time it cooled down to 74 degrees Fahrenheit. Based from the information given, the room temperature or the ambient temperature TA is equal to 21 degrees Celsius. The next thing we have to do now is to convert Celsius to Fahrenheit for our answers to match. We now have TA is equal to quantity 21 degrees Celsius times 9 over 5 plus 32. We now have the value for our ambient temperature, which is 69.8 degrees Fahrenheit. Given the values we have obtained from our data, we can use this information for us to solve for the general solution we have obtained a while ago. We have at small t is equal to 1 hour, capital T or the temperature is equal to 74 degrees Fahrenheit. We substitute this given information to our general solution. T is equal to quantity To minus Ta times e raised to the negative kt plus Ta. Substituting these values, we now have 74 is equal to quantity 76 minus 69.8 times e raised to the negative k times 1 plus 69.8. Simplifying the equation, we now have 74 is equal to 6.2 times e raised to the negative k plus 69.8. Transposing 69.8 to the left side of the equation, we now have 74 minus 69.8 is equal to 6.2 e raised to the negative k. Simplifying the equation, we now have 4.2 is equal to 6.2 e raised to the negative k. Solving for k, we now have k is equal to 0.39. For us to solve the crime and to know who the murderers of Mr. X are, we will have to know the exact time of death of Mr. X. Based from the given information, Mr. X's body temperature prior to his death was 98 degrees Fahrenheit. This will be our TO at small t is equal to 0. We denote x as the time of death of Mr. X, and 76 degrees Fahrenheit to be the temperature recorded by his neighbor during the time of death. The next thing we do now is to set t equal to x. So we can have capital T as a function of x be equal to 76 degrees Fahrenheit. We now substitute the values we have obtained earlier from our equation to the general solution. T is equal to quantity TO minus TA times e raised to the negative kt plus TA. Substituting these values, we can now have 76 is equal to 98 minus 69.8 times e raised to the negative 0.39x plus 69.8. Simplifying the equation, we will obtain 76 is equal to 28.2 e raised to the negative 0.39x plus 69.8. Transpose 69.8 to the other side. 76 minus 69.8 is equal to 28.2 e raised to the negative 0.39x. Simplifying further, 6.2 is equal to 28.2 e raised to the negative 0.39x. Solving for the value of x, we will obtain 3.88 hours. Now, using the values we have obtained from the problem, we can now determine the time of death of Mr. X. We can do this by subtracting 3 hours, 53 minutes, and 2.52 seconds from the time when the body of Mr. X was found, which is 6:30 a.m. Doing this, we now find out that 2:37 a.m. was the time of death of Mr. X, which leads us to the conclusion that the two middle-aged men are the murderers of Mr. X.
Here's a question. Why?
Because we can.